Next, we discuss ratio test or the Alemberts ratio test. If series UN is a positive term series and limit n tends to infinity, un upon un plus 1 is L, then series un is convergent if L greater than 1. Series un is divergent if L less than 1. Note, if L equals to 1, the test fails. That is, no conclusion can be drawn about the convergence or divergence of the series. The series may converge or it may diverge. Note, when ratio test fails, you can apply fourth test, that is comparison test, Gauss test, Rabi's test, and log test. If nth term of un contain x term, factorial term, or increasing multiple terms, in that case, we have to use ratio test. And when ratio test fails for L equals to 1, we can use comparison test. When ratio test fail, you can apply 4 tests: comparison test, Gauss test, Rabi's test, and log test. See one example. Examine for the convergence or divergence of the series 1 square, 2 square, factorial 1 plus 2 square, 3 square, factorial 2 plus 3 square, 4 square, factorial 3 plus so on till infinity. First step is to find un. Now, on account of symmetry, here this is u1, this is u2, this is u3. For denominator in u1, there is 1 factorial. In u2, 2 factorial. In u3, 3 factorial. So in un, we have n factorial. For numerator, in u1 we have 1 square and next is consecutive term 1 plus 1 2 square. For u2 we have 2 square and next its consecutive term 2 plus 1 equal to 3 square. For u3 we have 3 square and next its consecutive term 3 plus 1 equal to 4 square. So for un we have n square into its consecutive term n plus 1 square. This is our un. You can check un after finding it, as it may be wrong. Compare it. Put n equal to 1 and check value of u1. Then put n equal to 2 and check value of u2 and compare it. It means our un is correct. Now, there is presence of factorial term. There is presence of factorial in un term. So, comparison test is not applicable. Here we can apply only ratio test. And when it gets fail, then we move to another test. For ratio test, we have to find un plus 1. For n plus 1th term, we have to replace n by n plus 1. We have to replace n by n plus 1. What we will get? un plus 1 equals to n plus 1 square, n plus 2 square upon factorial n plus 1. Next step is to find un upon un plus 1. What we will get? N square factorial n plus 1 square. No, n plus 1 whole square. This will get reciprocal. This will get cancelled out. N plus 1 factorial can be written as n plus 1 into n factorial, so that we can so that n factorial will get cancelled out. Here n factorial will get cancelled out. Next step is take higher power of n common. As in all tests, we have to make n infraction and we have to take limit and tends to infinity. Therefore, un over un plus 1 will be n square into take n common. Take n common, n square will power is 2. So n square will get cancelled out with n square. Do as many cancellations as possible. And after it, we have to take limit and tends to infinity. Don't take limit and tends to infinity before cancellation. Note one thing. Here it is infinity into 1 plus 0 over 1 plus 0 whole square. Infinity into something is infinity, and infinity is greater than 1. Therefore, by ratio test, series U1 is convergent by ratio test. See one more example. Discuss the convergence of the series 2 upon 1 plus 2 into 5 upon 1 into 5 plus 2 into 5 into 8 upon 1 into 5 into 9 plus 2 into 5 into 8 into 11, 1, 5, 9, 13 plus so on till infinity. Note, in this series, we have increasing multiple terms. As in U1, we have one term. In U2, we have two terms. In U3, we have three terms. So in UN, we have n terms. So comparison test is not applicable. For this type of series, we can apply only ratio test. The given series is 2 by 1, 2 into 5, 1 into 5, 2 into 5 into 8, 1, 5, 9, 2, 5, 8, 11, 1, 5, 9, 13, and so on. Now, UN. See, in numerator, clearly first term is 2 in each term. So in UN, first term of numerator is 2. Next term is 5, 5, see 5, 5, 5. So in UN, next term is 5. See, next term is 8, 8. So next term is 8. Next is 11. 11. See difference. Difference is 3. Difference is 3. So after 11, there will be 14. So for nth term, we use the formula for Tn equals to A plus n minus 1 into D. Here A is 2, D is, see, difference 3. Simplify it. 2 plus 3n minus 3, 2 minus 3. It is minus 1. So last term is 3n minus 1. Now see observe behavior of denominator. For denominator, first term is 1, second term is 5, then 9, and similarly last term Tn is A plus n minus 1D. Here A is 1, D is 4. Therefore Tn will be 1, 5, 9, 13. Say difference. 4, 17. Tn is If difference is more than 1, we have to use this formula. A plus n minus 1 b. Here A is 1 and common difference 4. 1 plus 4n minus 4. It will be 4n minus 3. This is un. Next step is to find un plus 1. For un plus 1, replace n by n plus 1. What we will get? Or add, difference is 3, so add 3 here. And for next term, add, difference is 4, add 4 here. What we will get? un plus 1 will be 2, 5, 8, 11, 14, 3n minus 1. Never skip this term. Must write this term. Otherwise, confusion will be created. Next term, add 3. Minus 1 plus 3 is 3n plus 2. For denominator, 1, 5, 9, 13. Must write last term. Never skip last term. And add, difference is 4. Add 4. Minus 3 plus 4. It will be 4n plus 1. Note, never skip 3n minus 1 and 4n minus 3. Otherwise, confusion will be created. Next step is to find un over un plus 1. No need to write all these terms in un over un plus 1 because n terms will be cancelled out and we are left with only last term of un plus 1 which is not present in un, but you have to write it in reciprocal form. Next step is in reciprocal form. Therefore, un upon un plus 1 is 4n plus 1 upon 3n plus 2. Now, what is next step? Next step is to take higher power of n common, as we have to bring n in fraction in all the tests, as we have to take limit n tends to infinity. Therefore, take n common. What we will get? 4 plus 1 by n. Take n common. What we will get? 3 plus 2 by n. N will get cancelled out. Now take limit n tends to infinity. What we will get? 4 upon 3, as 1 over infinity is 0. 4 plus 0, 4. 2 over infinity is 0. Something over infinity is 0. 3 plus 0 is 3. 4 over 3 is greater than 1. Therefore, series un is convergent by ratio test. Therefore, given series is convergent. See one more example. Discuss the convergence of the series 1 upon 2 under root 1 plus x square 3 under root 2 plus x raised to power 4 upon 4 under root 3 plus x raised to power 6 upon 5 under root 4 plus so on till infinity. The given series is UN series is 1 upon 2 under root 1 x square upon 3 under root 2 x raised to power 4 4 under root 3 x raised to power 6 5 under root 4. Note, in numerator we have difference of power of x as 2. Like in second term x square, in third term x raised to power 4 and so on. So for symmetry we can write x raised to power 0 in first term because something raised to power 0 is 1. As if first term of series is not resembling with other terms, we can either skip it or try to make it resemble with other terms if possible on account of symmetry. Now for UN term. See, for denominator, we have square root of 1, square root of second term, square root 2, third term, square root 3. For UN, square root of n. For 1, 2. For 2, 3. For n factorial, for square root of n, we have n plus 1. And for powers of x, we have difference of 2. Difference is greater than 1. We use formula Tn equals to a plus n minus 1 into d. Here a is 0. Difference is 2. What we will get? X raised to power 2n minus 2. This is our nth term. For n plus 1th term, replace n by n plus 1. Or for now we have to write n plus 1th term. Or in powers of x, we have difference of 2, so we can add 2 in powers of x. We get un plus 1 equals 2. When we add 2, we get x raised to power 2n. Here, n plus 1. Replace n with n plus 1, n plus 1 plus 1, n plus 2. N with, replace n with n plus 1. What we will get? What we will get? Square root of n plus 1. Next step is un upon un plus 1. What we will get? 1 upon n plus 1 square root of n x raised to power 2n minus 2 into reciprocal it n plus 2 n plus square root of n plus 1 upon x raised to power 2n. Now cancel terms as much as possible and taking higher powers of n common to make n in fractions. What we will get? Take n common. Splitting the parts, x raised to power 2 and minus 2 will become positive 2 in denominator. Take n common. Take under root n common. This will get cancelled out. N will get cancelled out. Square root n will get cancelled out. We are left with what we will get. 1 over 1 plus 1 by n, 1 over x square, and 1 plus 2 upon n into square root of 1 plus 1 by n. Take limit n tends to infinity. This is 0, 0 plus 1 is 1. This is 0, 0 plus 1 is 1. This is 0, 0 plus 1 is 1. Square root of 1 is 1. We are left with 1 over x square. Therefore, by ratio test, series UN is convergent if 1 over x square greater than 1, that is, if x square less than 1. As we don't know the value of x, so we have to write all the cases. Don't try to find the value of x. Keep x square as x square. Now it is divergent, and divergent if 1 over x square less than 1, that is if x square greater than 1. When x square equal to 1, ratio test fails. As if value of limit is 1, then ratio test fails. When ratio test fails, we can apply 4 tests, namely comparison test, Rabi's test, Gauss test, and log test. But till now, we have discussed only comparison test out of 4 tests. So we try it with comparison test, because when we put x square equals to 1 in un term, we don't have x term, factorial term, or increasing multiple term. We have only simple term. So we can apply comparison test after failure of ratio test. See how. When x square equals to 1, then un will be 1 over n plus 1 into square root of n. Taking higher power of n common, basis same, powers are added. 1 plus 1 by 2 is 3 by 2. Let Vn is 1 over n raised to power 3 by 2. Therefore, un over vn will be 1 over 1 plus 1 by n. Next step is to take limit n tends to infinity. Limit n tends to infinity un upon vn. It will come out to be 1, which is finite and non-zero. Finite and non-zero. Therefore, by comparison test, series un and vn behaves alike. Here, series vn is, see, here p equals to 3 by 2, which is greater than 1. Therefore, series vn is convergent by p test, implies series un is also convergent by comparison test. Remember one thing, if there is presence of x in the series, then ratio test always get failed. If there is presence of x in the series, then ratio test always get failed at x equals to 1 or at x square equals to 1. In first two examples, x is not present. So we get limit greater than 1 or less than 1. In this example, after failure of ratio test, we get series un is convergent at x square equals to 1 with the help of comparison test. After solving it, you have to make summary of the result, that when your series is convergent or when your series is divergent. Therefore, series un is convergent for x square less than equals to 1 and divergent for x square greater than 1. See one more example. Examine the convergence of the series summation under root n under root of n square plus 1 into x raised to power n. Here un term is given, so no need to find it. Here x term is present in un, so we can apply ratio test. Here un equals to square root of n over square root of n square plus 1 into x raised to power n. For un plus 1, replace n with n plus 1. What we will get? It's your wish. You can expand it or you can take it as it is. Next step is to find un over un plus 1. This will get reciprocal. Here n plus 1, make correction. Take higher powers of n common. Under root n square common means n common. And splitting the parts, what we will get? Under root n square means n. Under root n square means n. Splitting the parts, this will get cancelled out. This will get cancelled out. This will get cancelled out. Now take limit n tends to infinity. One over infinity is 0, 0 plus 1, 1. 1 over infinity is 0, under root of 1 is 1. Here it will become 1, here it will become, we are left only with 1 by x. We are only left with 1 by x. Now we don't know the value of x. Therefore, by ratio test, we make summary of result or we write all the cases. We write all the cases. If 1 by x greater than 1, that is if x less than 1, series un is convergent. If 1 by x less than 1, that is x greater than 1, series un is divergent. If 1 by x equals to 1, that is if x equals to 1, ratio test fails. When we put x equals to 1 in un, it becomes simple. So we can apply comparison test. So put x equals to 1 in un, what we will get? Take higher power of n common. Under root of n square, it is n. N my power 1, its power 1 by 2, 1 minus 1 by 2. It will become 1 by 2. You have to suppose this term as Vn. Therefore, un upon Vn is take limit n tends to infinity, we get 1. which is non-zero and finite. Therefore, by comparison test, series UN and Vn behaves alike. Here, series Vn is here T is 1 by 2, which is less than 1. Therefore, series Vn is divergent by T test. Implies series UN is also divergent by comparison test. As by comparison test, series behaves alike. Now we have to compile all the result or make summary of the result. Finally, we have and series UN is convergent for x less than 1 and divergent for x greater than equals to